Hey guys, so welcome to the part 2 of the video. Now, in this video, what we're gonna do is we're gonna complete what we started in part 1, but we're gonna make the most efficient implementation of our robot program. Now, in order to do that, so the way we see this is when we lift the bar up, we don't need to lift it all the way to the maximum height. We need to lift it just enough so we can pass the highest obstacle, whether it be the highest bar plus the block number 3 or the highest block stack. So in order to do this, first we need to define what that highest obstacle actually is. So let's call it clearance. I've written some code before, so clearance initially would be equal to 0. And what are the possible highest obstacles on our way? So one of the possible highest obstacles will be the all of the blocks at the block stack at source 10. So all block stack would be one of the considerations. So for example, 3, 3, 3, 3, that would be 12. Then another consideration would be the 2 block stack, which would be here. Imagine if we were at the position 0 or the position 1, and there were a bunch of blocks of size 2 stacked over here. So that would be a consideration. And the maximum bar height. So maximum height of a bar would be a consideration. For example, be it 7 or be it 7 plus 3, which is 10. So inside of our, so first of all, we're gonna find out what the maximum height of the bar is initially. So we're gonna run this little for loop here, and we're gonna say iterate through all of the elements inside of the bar height array, and we're gonna say if maximum bar height, which initially was 0 as we defined it over here, is less than the current element in the bar height array, which is the height of the bar, then we're gonna just say that the maximum bar height is equals to the bar height at that element. And we're gonna keep iterating through it, and this way it's gonna find the maximum value. Then we're going to go ahead and we're gonna add all of the all blocks height from the blocks height array. So it's gonna be add one on top of the other, and that's gonna give us the height of all of the blocks stacked at source 10 initially. Afterwards, when we're gonna run our main loop, let's just go ahead and add a comment here saying that this is the main loop that is running for all of the blocks. So I'm not confused. And then we're gonna have to find out what the clearance is on each pass. So if the pass, so let's find it out. So if W is greater than or equals to 3, which means that if our the width, so if W is so if our position is anywhere at 3 or greater, that means that we don't need to consider the stack of blocks of size 2 as a consideration moving forward. We don't care about this because we're only moving forward that way. So in this case, it's not a consideration. So the clearance in this case is so if the maximum bar height, one of these, is greater than the height of all of the blocks, then our clearance is the maximum bar height. Otherwise, our clearance would be the size of all of the blocks. Otherwise, if W is not greater than 3, which means we're somewhere in the beginning, meaning either 1 or 2, that means we have to consider we have to take everything into consideration, so all 3 of those values. So in this case, if the maximum bar height is greater than all blocks height, that means clearance is the maximum bar height initially. But then again, if the maximum bar height is also greater than the 2 block stack, then the clearance is maximum bar height. Otherwise, if this stack here of blocks number 2 is greater than the max bar height, then the clearance would be the 2 block stack, because this would be higher, and that's what we would care about if we were here, for example. Otherwise, if this is higher, the all block stack, all blocks height, then that would be the clearance, and that would be the clearance. And otherwise, if it's otherwise the clearance would be the 2 block stack if this would be greater than the all of the blocks stack. So this would define our clearance on the passing on the pass forward. Then again, so we're gonna debug it. So then again, while D is less than clearance, so D is our the actual thing that's gonna hit something if it's lower than clearance. So while D is less than clearance, then D, so if D is less than H minus 1, which means that D has some go to it still, then we're gonna raise it. And otherwise, if D has no further goal left to raise it, then what we're gonna do is we're gonna lift the H up, and of course both of those values go up because D rises with the H. Then we're gonna do what we've done already in part 1 of the video. So we're gonna extend, we're gonna pick it up. Now once we picked it up, here's our pass going backwards. So we need to consider clearance again. Now going backwards, we have to consider everything. What's our block size? So if our block size is of size 3, the only thing we need to consider is the maximum height of the bar. That's the only thing we need to consider. Now, if our block size is of size 2, the only thing we need to consider is the maximum height of the bar plus the size of the stacks at block of size 2. Now, if our block is of size 1, then what we need to consider is everything. So the maximum height of the bar, the height of all of the stacks at target 2, and the maximum height of all of the blocks of size 1 at target 1. So let us implement this real quick. And so we're just gonna consider clearance. So we're gonna say if, and we say current block is of size 1. So current block is, let's go ahead and start with 3. So if current block is of size 3, then what do we need to consider? We need to consider only the highest bar. So clearance would be equal to max bar height. And that is the only thing we need to consider in that case. Otherwise, so else if current block is of size 2, then we need to consider between maximum bar height and the size of the blocks at stack 2. So what we're gonna do is we're gonna say if max bar height is greater than 2 block stack, then clearance would be equal to the max bar height. Otherwise, clearance would be equal to the 2 block stack. Okay, that's if the block is of size 2. Now, else, if the block is of size 1, we need to consider all 3 of these things. So max bar height, 2 block stack, and 1 block stack. So let us do this. So if clearance is not clearance, if max bar height is greater than 2 block stack, then also we're gonna check if max bar height is also greater than 1 block stack, then our total clearance would be max bar height. It's equal to max bar height. Now, otherwise, if max bar height is not greater than 1 block stack, then our clearance would be equal to 1 block stack. That's how we go about it. And then on this condition, so else meaning if 2 block stack is actually greater than max bar height. So if so in this case we need to consider between 2 block stack and 1 block stack. So let's go 2 block stack is greater than 1 block stack. In this case, what's greater? Clearance will be equal to 2 block stack. And by the way, this is exactly what I've done on the pass forward. So pass backward is almost the same thing. If you're keen on efficiency and less code, you can take it out and put it into a separate function with different parameters. But we're doing like this for simplicity's sake. So yeah, else. So if 2 block stack is not greater than 1 block stack, then clearance will be equal to 1 block stack. And that should do it. And then over here, instead of raising it plain and simple, d some blah 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 greater than h, what we're gonna do is we're gonna implement the same strategy. So while d is less than clearance, what we need to do is so if d is less than h minus 1, then we can raise it. Raise, and of course d plus, and it raises. And otherwise, so if D has no more go left to it, we're gonna go R.up. We're gonna lift up the main arm of the robot. And then we're gonna it's gonna be H++ and D++ because they're both gonna be going up. And we can get rid of this line here. And then it's just gonna contract and lower and assemble as follows. So let us see if this actually works. So if we made a bunch of mistakes here that will lead to bugs. So let's go ahead and run compile the code. So to compile it, as we can remember, we go Java, we compile all of the code that is ending with .java, and we're gonna run robot in order to run the code. Let's see. So it lifted just enough, and it lifted on the pass backwards just enough. So that works for all the blocks of size 3 and all the bars of size 10. So let's swap it around a bit. Let's change some block sizes and some bar sizes. Let's keep the block sizes the same for the second passover, and let's change the bar sizes. So let's go all of them 2. So 2, 2, 2, 2, 2, 2. So that should be 12. Let's go ahead and run this and see if it still works. So it's gonna lift it just enough each time, no higher than needed, in order to grab on. So on the path backwards, we don't seem to be considering the max bar height. So, which is our problem because we didn't lift it high enough. Okay, let us see what's wrong. So on the path forward, it worked perfectly. Now on the path backwards, we need to return it. Let us check. So if current block size is equal to 2, which is what it was equal to, so what we got here, if maximum bar height is greater than the 2 block stack, which it should have been, because as we can see, maximum bar height is 7, and the 2 block stack is only 4, so it should have lifted it all the way to 7, but it lifted it to 6, meaning that if maximum bar height is greater than 2 block stack, then clearance was equal to max bar height. So did we actually do this, or did we go to the other one? Let's just say we did this, and also let's actually output what the value of the clearance is in our case, and the value of D, which will be helpful. So let's go ahead and just click OK and compile the code. Forgot the semicolon. Okay, let's compile the code, and let us run the code again with the same configurations. And it's gonna, of course, it's gonna fail again. But what we're interested in is these variables. So we did this. Yes, I actually did that, and the value of clearance was 7, and the value of D was 8. So the value of clearance was 7, the value of D was 12 initially, yes. Then the value was 10, then the value was 8 as we lower the size of the block. And the value of clearance is 7. So as the value of D was 8, which was correct, but we didn't consider right. So basically, it's considering the size of the height of D, and it's thinking, oh yeah, D passes by the block size of by the maximum D passes by the maximum obstacle, no problem at all. But what we didn't consider is it's actually D plus the current size of the block, because that's what we're dragging with us. So D is longer by 2. So what we need to do here is we need to for each one of them, by the way, not just for size 2. I'm glad we spotted this. So in the case of clearance, so in the case of actually lifting it up, while D is greater than clearance, so it shouldn't be while D is less than clearance. It should be while D plus current block is less than clearance. And that way, we're gonna grab, so D is not just the drop bar by itself, but as it's dragging the block, which didn't factor into the pass forward, but it did factor in the pass backwards because we're actually having the block with us. So while D is plus the block that we're dragging with us is less than clearance, then we're gonna keep lifting it up. So let's go ahead and compile this and run it again and see if that actually works. All right. So works well. Did we compile it? We did compile it. So it's still 7 plus 8. So why did I add this on? So while d plus current block is less than clearance, we're gonna raise it and then we would contract it. So it should be here. So while d plus the current block, so and then while the else r dot up, what doesn't it? So d plus current block is less than clearance. So let's go ahead and print out over here the values so as to debug it. So we did this over here. Then we need clearance. It's not clearance plus d because yeah, clearance plus d is right. Also, of course, that's just gonna give us the sum of these two values, which I don't think it will. So if you print it out over here, so what we need to know what the clearance is, and we need to know what the d is. Let us check. Okay, so 712 initially, 710, and then 7-8. Right. So clearance was 7, which was correct, and d was 8, which is also correct because d is at height 8. So d should have been lower in this case, not 8. Because d is technically speaking at 6, because it should be d plus the size of the block. So d is 8 plus the current block, right? So I think the way we did it, it's a bit confusing and counterintuitive, but the way we did it, it should actually be minus because it's gonna be lower than higher. So it should be d minus the current block, not d plus the current block, because the way we did it is not is by counting it. So the higher the d is, the further away it is from our obstacle. So if d, we didn't compile it. So let's go ahead and compile it and run the code, and let's see if that will speed it up a bit. And so d minus, yeah, this way it actually works. So it was supposed to be d minus the current block. Yep. And then it leaves just enough to get it right. Perfect. So this actually works. Let's go ahead and get rid of our line for debugging. And let's see if it works for other types of blocks. So let's go ahead and say instead of 2, 2, 2, we go 1, 1, 1. So 1, 1, 1, 1, 1, 1, 1, 1, 1. Wait, I lost count. So let's go 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That should be 12. Let's speed it up so we don't have to watch all of this. Yep, it works well, as we can see. For all of the sizes of I didn't compile the code, which is why I was still outputting that stuff to the console, which I shouldn't because I deleted the system.out print line. So this should work for all of the different sizes of blocks. So let's go ahead and run it with another configuration just to check. So it's the random bars and random blocks. So let's go 3, 2, 1, 7, 4, 3. That's the sum of 6 bars. And for the blocks, let's go ahead and say 3, 2, 1, 3, 2, 2, 1, 3. So how many is that? 5, 6, that's 9. So this is 11, and so 11 and 12. So this is 12 bars. Yep, perfect. Let's see if this works. So we go ahead and put it in blocks at 1. This should go to 2. Then this should go to 3, and this should go to 1. This should go to 2, and at least it's just enough. This should go to 2. Yep, it worked. So let's go ahead and you know what would be interesting? We'll make the first, we'll run the same exact configuration, but we'll make the first bar of size 7 just to see if it passes 7 plus 3, just to check it again. So we go ahead and make the first bar of size 7, and we'll just run it again. And see if it will speed it up a little bit. Yep, so we don't actually consider, so maximum bar height is for some reason only 7, and it didn't consider it a 7 plus 3. So once we put the block of size 3 onto the bar of size 7, we should have updated the maximum bar to be 7 plus 3. So let's see why that didn't happen. So when we so if the block of size 3, so when we lower it, so we lowered it, then what we did, we updated the bar index. So we've updated the bar, the target of block 3, and we go a current block plus bar height at bar index, which should have been our bar, right, is greater than maximum bar height. Then the maximum bar height would have been current block plus the current bar at bar index. So if this ran, so let's just go ahead and comment update max bar. So updating the maximum bar height, and let's just make sure that the clearance runs each time, right? So once we pick it up, it checks up the clearance each time. So maximum bar height should have been updated over here, unless of course bar height at the bar index is not the correct variable and it doesn't give us the correct value. So let's go ahead and print it out. Print out. So what we need is bar height and bar index. What we're interested in is this. And let's go ahead and print it out over here. Run the program, compile the program first. Oh yes, semicolon, of course. Semicolon, my friend. So let's go ahead and compile it and run the program and speed it up and just see what kind of out. So it's 2. Yes, it is 2, the current bar height. But before, when I was putting it on, it should have been 7, not 2. And the reason this happened, I think I can see the reason this happened, is because we actually updated the bar index before we worked out what the maximum height is. So let's go ahead and cut this and paste it before actually updating the bar index. So I will take the bar index of the bar that is of size 7 instead of the next one, which of size 2. So let's go ahead and get rid of this and compile the program and let us run it again, and I believe this will actually work. Let's speed it up a little bit. Yep, now it passes over because it's updated the maximum height of the bar. And I noticed another little error right here. I'm not sure if it's spotted or not, but let's go ahead and run it again and I'll show you exactly what's wrong. So I'll speed it up initially. Let's slow it down right here. So you see how it lifts it up, and then it comes ahead and picks up the block number 3, and it lifts it up higher than it needs to. It doesn't need to be that high, so lift it up over the maximum bar height of blocks of size 3, but it's irrelevant because we're never gonna go over this bar. We're only gonna go ahead and lower it on bar of size 2, so we don't need to consider this particular bar anymore. We only need to consider all of the bars that come before it. So in order to fix this, I actually haven't thought of this before. I just noticed that it didn't do exactly what it was supposed to do, so I noticed it just now. So in order to fix this particular hiccup right here, what we would need to do is we would need to have a separate array going for all of the max bar heights that is only going to be in consideration for when our current block is of size 3. So let's go ahead and say we'll just define another array called max bar height. So we go ahead and bar height, but we're gonna call it bar height 3 because it's only in consideration for all of the blocks of size 3. And initially, that's just gonna be equal to bar height. So it's gonna be the same thing. But as we go on forward, what we will do is we'll actually so the maximum bar height will be, so if the block is of size 3 on the path backwards, right? As we lower the block, so we also need to have a consideration of the maximum bar height. So another variable, maximum bar height, 3 as well, and it's initially gonna be 0. And actually, we'll be better off defining it over here after we define the first one. So let's go ahead and say that the maximum bar height is actually equal to the normal max bar height initially. But then, so if our current block is of size 3 on the pass backwards, after we picked it up, right? So the clearance is equal to, so if current block is equal to 3, the clearance is equal to max bar height. But instead of this, what we're gonna do is we're gonna say the clearance is equal to maximum bar height 3, and we're going to work it out over here instead of over there, so that makes sense. So we're just gonna copy and paste this and do exactly the same thing over here. So we're gonna work out what the maximum bar height actually is each time when our block is of size 3. So it's gonna be max bar height 3, just so the max bar height 3, and bar heights 3 dot length. So bar heights 3, bar heights 3. Clearance is equal to bar heights 3, max bar heights 3, after we work out what that is. Now the key difference here will be that after we put the block down, so over here we update everything for blocks of size 3. Another thing we're gonna do is we're gonna say before we update the bar index, is very important. What we're gonna say is simply this: bar heights 3 at index of bar index, which is where we just put the current bar, is now equal to 0, because we don't care about that bar anymore. It doesn't matter how high it is, we're not gonna go over it, so we don't care. It's still an important consideration for blocks of other sizes, but just not for blocks of size 3. So now we've removed it from consideration. So then when it's gonna calculate the maximum bar height from the array of max bar height 3, that initial bar is now gonna be 0, so we don't no longer care, and it's only gonna consider the next highest bars. So let's go ahead and compile it and run it and see if that works, or if we made a mistake and it's gonna bug out. Let's see. Let's compile everything that is the Java. Java. What's wrong? Array required but int found. All right, because we didn't define it correctly, I'm guessing. So it should have been the array. So will that work? For I equals 0. Right, so I was already defined in the scope of our block because we're already in the loop. So we're trying to write another loop within the loop that already contains an I. So let's just say it's no longer I. Let's call it J, a different kind of variable. So everything that is I is now going to be J, because I is already defined within the scope of this particular loop. That is our main loop that is iterating through every single one of the blocks in order to complete the program. So now that everything is J, the compiler should be happy. Yes, it is. Let's now run the program and see if it works perfectly. But I don't care about running the program. Actually, let's do it for interest's sake. Let's see. Yeah, it still works. Okay, let's go ahead and run it for our previous configurations. Let's speed it up just a little bit and see if it works. So that still works. For 1 still works. For blocks of size 2, that still works. Now let's see how far it lifted. Yes, it lifted just enough. It lifted it over the bar 7 because we no longer cared about 7 plus 3. So it worked perfectly well. Now another interesting test to run on this will be, instead of having different let's have all of the blocks of size 3 but keeping the bars the same heights. So now it's a bit of a challenge. Let us see. So it lifted just enough. It lifted just enough to be to pass. And actually I think I noticed an error. Let us check. So let's see. So it lifted it just enough to pass, but then it lifted it way more than it needed to because it was considering the maximum bar height instead of considering just the maximum height of these two, so the maximum bar height. And to fix this little problem, and I believe it's going to be our last problem, is just do the same kind of consideration over here, but in the beginning for the pass forward. So for the pass forward, if our block is equal to 3, and we know this based on W, so if W is greater than or equal to 3, we know that we've just dropped a block of size 3, and we're going forward without needing to consider the blocks of size, the stacks of size 2 and the stacks of size 1. So all we need to do right here is basically check with max bar height 3 instead of the max bar height. And the max bar height 3 would have been worked out beforehand when we drop the block. So in the scope of this, we just need to check if was max bar height 3, and I believe this should work because we already worked out if max bar height 3 was when we dropped it off. We don't need to work it out again over here. So let us see if let's compile the program. Let's go ahead and run it and see what happens. Speed it up a little bit, but not too much so we don't miss crucial things. So now I'm gonna drop it over here. Yeah, it does not go higher than it needs to. It went just high enough to pass over the maximum bar obstacle. So this works, and this is indeed now the most efficient implementation of this particular robot program that does everything in the minimal amount of moves. So as I said, it'll be really good practice for you guys to go ahead and download this program. Just clone it from my GitHub repository and copy it up, clone it from there, delete all of the code that is governing how the robot moves, and simply do it on your own and see if you can come up with the most efficient implementation yourself just by iterating through, and if it bugs out, debugging it with print statements, and eventually you'll be able to do it yourselves. Now, as I said in part 1 of the video, this particular programming challenge is amazing for practicing concepts such as the if statements and the loops, because there are a lot of them in this program, and each one of them is paramount to actually making the program work, and it's not trivial at all. So thank you for watching the part 2 of this video. I hope you enjoyed this challenge as much as I did, and as always, I'll see you in the next one.